So, yes, welcome everyone to the June WA RACI Camaraderie. Glad to see you all here today, and we've got a few visitors from our students that are doing the titration stakes upstairs. So apparently we've got 96 students upstairs practicing their titration skills. So yes, exciting that we can be doing these outreach for young upcoming chemists, hopefully. So I'd like to start by acknowledging the land that we're meeting on today, and acknowledge the traditional custodians, the Whadjuk Noongar people, and I wish to acknowledge and respect their continuing culture and contribution they make to the life and the city in this region. So without further ado, I'd like to introduce our speaker for today. It's Associate Professor Daniel Southam from Curtin University here on campus. He's going to be talking about the power of dialogue in learning chemistry. So I thought that was quite apt, considering all the students we've got upstairs and the teachers that we have joining us today. So Daniel he's got not just a lecturer here at Curtin. He holds roles in the Director of Innovation Technology in the Faculty of Science and Engineering and the Deputy Chair of the Curtin Academy. He's a passionate advocate for active learning, and he crafts engineering and social environments and blends the effective use of technology and reflective practice to support student development of skills necessary for lifelong learning. And one of the main reasons we did invite him along today as well is because he was awarded the Fensham Medal by the RACI last year for outstanding contributions to chemical education, and he's also the chair of the Institute's Accreditation Committee. So yes, it's lovely to have you along, Daniel. So please.
Thanks, everyone. Nunquell Daniel Southam. And I'd also like to acknowledge the traditional owners of the countries that connect my life in two parts together. And I often say my story is one that's connected by two rivers. On the left is Kanamaluka and also Pliptamila, which is Lutruwita, the land, sky and sea of the Tratnapana people, Pakana, Palawa, in Tasmania. And on the right is Derby Errigan, land, sky, sea, waters of the Whadjuk people of the Noongar Nation. I'd like to pay my respects to the elders past and present, and through them to all Indigenous members of our community. So, as Terry just mentioned, I'm going to talk a little bit around the power of dialogue in learning chemistry. I'm going to take you through a couple of vignettes from my own practice of things that I try to do to encourage dialogue in the classroom, and information within that space that allows learners to understand not only how they learn but how the people around them learn, to build understanding of their cognitive processes. Now, as Terry mentioned, I was awarded the Fensham Medal, and you might ask, well, who is Fensham? Fensham was Peter Fensham, Emeritus Professor Peter Fensham. And he had a background in chemistry, a PhD from Bristol, 1952. He'd done his Masters and undergrad at the University of Melbourne. And he also, one of those strange beasts that likes to do more than one PhD, did one in social psychology from Cambridge in 1956. He brought those ideas back to Australia, where he was appointed the first Professor of Science Education at the University of Melbourne, and established ASERA, which is this Australasian Science Education Research Association. And particularly I take from his work this idea, an ethos that science is more than just a subject, but is actually a mechanism for social change. And Science is for All, which was one of his seminal papers from 1985. His earlier work from the 1970s actually helped shape educational policy of the Whitlam government. And so he was a person who enacted quite significant change in science education and also chemistry education as well. And so it's an apt naming of this medal of a person who created great change in how we practice education of science. So let me give you some background. I teach across the chemistry curriculum, less so these days. As Terry said, I've got a few hats. They take me out of the classroom, which makes me sad. And so I kind of insist that I still do a little bit of teaching, although that is diminishing the further I go on in my career. So I'm hoping I can still hang on to this. So as teachers in higher ed, we have quite a lot of autonomy over what we do. And the prevailing approach is that you set a bunch of outcomes. They're here on the left. Those outcomes, somehow through some assessment theory, you go to your assessment design. So you work out what you want to do, you do it, you work out what the assessment theory tells you is appropriate for that, and then you design your assessment. The part that I would posit is the part that's missing in a lot of what we do is this understanding of how students learn. And particularly in my area of chemistry, so I'm an inorganic chemist, I teach in primarily the spectroscopy, physical inorganic kind of space. I do group theory, so it kind of gets into mathematics, it's very abstract, but is an area that tells you a lot about how students learn in that spatial domain. And so I will hopefully convince you that understanding how your students learn will actually unlock the potential dialogue that then allows those students not only to learn more, but be able to succeed in their assessment. So, learning design. This should be, for teachers in the room, be fairly familiar. This particular model, Ron Oliver was at ECU for a number of years, rose right the way through to DVCA. This is his model of learning design, that somehow the learner resources, tasks and supports should overlap to converge with this concept of assessment. So what you give the students and how they engage with those resources through the tasks that you set them and the supports that surround them should in some way converge around the assessment. And so with these things in mind, let's give you an introduction to the unit that I teach. So the unit is a second year structure and spectroscopy course. Anybody that's done a chemistry major and people who haven't done chemistry majors have probably been introduced to these concepts. It covers, to start with, an introduction to symmetry, infrared spectroscopy, mass spectrometry, NMR, a brief introduction to coordination chemistry, because that's about where we need to fit it, and then a comprehensive laboratory program where the students are starting to learn about the fundamentals of synthesis. So mostly they're learning about isolation, purification, and then characterisation rather than the reactivity itself, which comes later in their course. But the real, what I would term pedagogical imperative, so that is the imperative for the instructional strategy that we employ here, is in the interpretation and analysis of spectroscopic data from both inorganic and organic compounds to elucidate in some form the chemical or electronic structure of that compound. So we know front and centre what our idea is. The approach that we take then is to put some structure to it. Now, for those who know me well, know that I tend to like to go to the literature to work out what strategies work. And so in this particular learning design, I've just picked out a few elements that I think are relevant, some of which I will talk to today. So in the resource and task space, we have a number of facilitated workshops that use a particular formalism to talk the students through how to understand the concept that we're presenting. So the activities themselves, they're called POGL, Process-Oriented Guided Inquiry Learning. It breaks down the concept into parts, and the students reconstruct that through a series of guided questions to then apply it through a number of different examples. We facilitate that in a workshop where the students are encouraged to talk to each other and to talk to us. The lecture content in this particular course is all pre-recorded, so the students can watch it before they come to class. There are no lectures. And they're given supports around that to come into the space. Firstly, we make sure that the teamwork is critically reflected, and I'm going to show you some examples of that in just a moment. And we use an element of diagnostic assessment to give students information about the approach that best suits their abilities, either innate or developed, in visuospatial reasoning. And again, I'll talk to that in just a second. Okay, so visuospatial reasoning is a big part of this. So talking through symmetry of molecular structure is quite challenging. Less so in the current day, because we can blend two-dimensional and three-dimensional models, but most of the resources that we use in this space are static. They're lines on a page that are somehow meant to represent a three-dimensional reality. And whether a student imagines what you intend will depend upon a whole series of skills that all fall in under this umbrella. So what is visuospatial reasoning? Well, it's using visual and spatial cues to solve problems. And that problem solution comes through abstraction, so identifying what parts are relevant to the solution. Representation, so using canonical or sometimes their own representations, and that can be linguistic, symbolic, or numeric. And then transforming it, doing something with that information. Now, these processes often go backwards and forwards across each of those domains. So you might transform something, then have to back encode it to a representation to be able to represent the answer, whatever that might be. And again, those representations can be linguistic, symbolic, or numeric. So, let's test your spatial ability. Have a go, and then have a chat to the person next to you or around you. What strategies did you use to solve that problem? Does anyone want to share their approach? Do I have to pick on people that I know? Emily, what do you reckon? What approach did you use?
I actually struggled a lot when I had technology because I don't have a mental ability.
You know some of the... You know the moral of this story, though.
For me, in that top line,
Yep.
everything's still pointing up.
Yep.
That is pointing up at the start.
Good.
And if you're looking at the bottom, there's only one where that's true.
Oh, there might be 2, 3,
Well,
B,
I guess, like,
B, D, and E.
So like the way it's facing, like you can
Yeah.
see that face. So
Who has a different strategy? Who's one of those rare and gifted people that can just imagine it in their heads?
I don't know that, but I think it was still the same orientation in terms of vertically.
Yep.
And it's being rotated, say, roughly 90 degrees.
90 degrees. Yep.
Therefore, you could now see the end face that you can't currently see.
Yep.
So it'd be a D.
D, who agrees? D? Awesome. All right, you did the easy one. Let's try a harder one. Let's see if we can apply those strategies together. And there'll be some debate over this one. No, nobody likes the right answer to this one. Okay, so I'll talk through the answer in a moment, and I'll show you through some of the tools that we use to help our students that might struggle with doing these ones in the time that we allow. There are some myths out there about spatial ability, and you'll see them rife in the literature because they're kind of alluring. They're what we call essentialist pitfalls. I can't learn that because, as Emily said, I'm not a visual learner, or I don't have those skills. And in fact, that's not fixed. We can learn how to be spatially aware. We can learn how to use and develop our visuospatial reasoning. But for some learners, it's just a little bit more challenging. The really sort of horrid ones are that there are sex differences. Males know how to do this. Females can't read maps. Males know how to do ... No evidence in the literature to support that. So they're not biologically caused. It's not evolutionary. There's nothing in the literature that allows you to make confirmed decisions on that basis. Some of the developmental literature will tell you that spatial ability is fixed, and it all comes back to Piaget. Anybody that's studied any literature on educational theory will know about Piaget and his sort of developmental theories. And he sort of says, oh, you can't start visuospatial reasoning until you're years old, and it's all fixed by the time you're 13. Not true. But the last is that spatial language determines spatial thought. And that's very much where chemistry falls over. We use a lot of canonical representations, sort of representations that we use for no other reason than we use those representations. And it occludes a lot of productive learning pathways that students can't navigate in the same way you did with that test. This sort of thing. You know, the minute I've thrown up, particularly coordination chem later on, we go from tetrahedra to octahedra. Students go, mind's blown. And you'll see a lot of this trying to get octahedra going and twisting them around for those same reasons, because the representations we use present them as a flat 2D image, and somehow you're meant to just imagine them in 3 dimensions. And so that's where chemists need to do better. So one of the things that we did was adapt some instructional strategies to help with that. So in my particular area, the strategies for learning group theory and symmetry are dense with these static and implicit representations. They are diagrammatic, they are numerical, they are symbolic. They're meant to imply a whole bunch of meaning that sometimes students don't actually get in the ways that you intend. So what we did was design some student-centred instructional strategies that granted some opportunities to permit multiple equally valid approaches to solving problems. And what we found is that deconstructing that expert understanding allows multiple equally valid approaches to learning. So I'll show you just a couple. First, I'll show you why. Here's item 30, but coloured up. Have a go. What do you reckon the answer is now? So this is my strategy. If you flip it up on, so the coloured points go to the top and it's rotated 180 degrees. If I do the same with that little yellow V shape, flip that up, 180 degrees, pointing the other way. So the answer, according to the literature, is E. That will bother probably about 80% of this audience, because it's when I give this one in a larger audience, I get 20%, 20%, 20%, 20%. And yeah, because everyone will come up and argue with me about it afterwards. I didn't write it, but there is some contention because that particular representation of E is not fantastic. It's hiding a lot of information in behind it that you don't actually see. Okay, so 2 dominant approaches to visuospatial reasoning were there. The imaginistic approach, so being able to imagine in your mind and do the rotation without having to think about it. And the analytic part, which is the part I just showcased then. Finding a feature, tracking that feature through step by step to get to a solution. Student spatial ability may dictate a preference, but lead to successful outcomes. One might take a little longer or need a little support, but both will get you to the answer. So here's an example. This is the part where the wheels fall off when I teach symmetry. This is what's called an improper rotation. Don't ask why it exists. I'd have to go into a whole lot of abstract linear algebra to explain it. But basically, you have to rotate something by an angle and then flip it. And those 2 things together are called an improper axis. So this particular strategy is chosen because some students love Newman projections at the top that just make sense, particularly in this particular case because it's a 6-fold rotation, so it's 360 degrees. And so you can kind of track the features. They can go, oh, there's H1 going to H6 and then flipping, and then you can kind of follow it around. Some students will prefer the side-on example. And then there's a third as well that's linked in of a website that students can go to, and it will do the process in a way that you can't do with a physical object. So we've got 3 different representations that students have choice over. We then get them to critically reflect on that process. Here are some things that you should do. Have a conversation in your group. The students work in teams of 3 or 4, so sometimes 5 or 6, depending upon the day. But having a conversation in the group exposes the sorts of things that we just talked about when we discussed our example given in the test, in the rotation test. Oh, I struggled with that. Well, I didn't. It was easy. What do you mean? And exposing those differences allows students to have empathy, obviously, for each other and how they learn, but also to understand why those different approaches are applied and to work to their strengths. We then challenge them, and this is where we get messy. So I generally like to have a room with lots and lots of whiteboards, but sometimes that's not necessary or available, so blue tack and A3 sheets of paper, and basically you get them working around the room. Because this is a process where eventually they should end up back where they started. And so they do that, working step by step. Some will work through the Newman projections, some of them will work through the line projections, but eventually they will end up back where they started. And it just gives a sense of satisfaction that they're doing the right things. So the question would be, well, are there any sex differences in your class? Well, yes. Males do better significantly, but with a small effect on the rotation test. So this is from 4 years worth of data. When I switched from the 20 item to the 30 item, I went online, so haven't included the preceding data, but the same thing was observed. But females perform significantly better on the overall course mark. 2 reasons for that. Not just what I do. How do I put this politely? The females that come to a chemistry course come because they excel in that space. We get a lot of mediocre males. Is that a fair statement? Alex? Yep. Yep. So that, I wouldn't say it's necessarily a consequence of this instructional strategy, but just a consequence of the sorts of students that we attract. Okay, so what about the dialogue? So imagine March 2020, hearing about this thing on the news. What would I be thinking of? COVID. The university says, oh yeah, we've got a plan, we've got lots of plans, and each one of them are worse than the next. What do you do? Well, I'm sitting there going, well, I don't know what we're going to do. Well, I don't know what we're going to do. And so I went, right, let's scrap this idea. Final exams aren't going anywhere. The system the university's created to invigilate exams has warts on it. Let's do something that we know we've got control over. We can set up a WebEx chat with our students and we have a conversation about what they've learned. Excellent, let's do that. So we did that. Many others did it too. But the approach that we took was more linked to the written assessment, in part to confirm that the students understood what they'd written down. Because you had that underlying concern, oh, they really need to know how to do this stuff. It's about problem solving. If they just go on the web and get a Chegg or one of those online websites that you can pay $20 and someone will do your assessment for you, what are we going to do when they hit next semester and they can't do any of this stuff? So we linked it to the written assessments that they'd done throughout the semester. It was framed as an academic discussion. So you're just coming into the teaching team. We'd done those discussions in class up until whenever it was, sort of Easter 2020. We continued doing it online in Blackboard Collaborate for us. And so we had some rapport with the students. And we said, look, this is an important professional skill. You're going to use these skills again in your professional career. And the approach that we took was what we call grade titration. Yep. So we start where they were on their written assessments and we titrate up and down, asking a series of questions that kind of got to, well, are you better than your written work or is there a little bit of work to do? Now what surprised us is students were really happy. Students knew a lot of stuff. So this is my co-teachers in it with a colleague, the two of us, one student, conversation, 20 minutes. We covered all the course content. We got a very, very accurate understanding of what the students knew, and the students got feedback on the spot. I went, this is actually feasible. So we kept it. We kept it for second semester in a related unit. We've kept it now for 4 years. 2020, 1, 2, yeah, just finished the 4th year. So we were surprised, and so the research room, we went, oh, what's going on? So here's an example of the sort of question. This is not facile chemistry. This is cutting edge stuff. Monty 2020, that came out of the lab here at Curtin. Colleague Max Massey and his group. That's not your average sort of molecule, well, ion complex, and involves the sorts of visuospatial reasoning that you saw in the previous vignette. And obviously that gave the students lots of opportunity. We had some IR, had some mass spec, had some NMR that we could interrogate them and get them to analyse, and it worked quite well. So the approach was structured around the solo taxonomy structure of the observed learning outcome. And the way I like to describe this is from knowing nothing at the pre-structural level to knowing maybe this one thing. Oh yeah, I learned about IR, I can do this, I've done that, here it is, I can do that one thing. To knowing a bunch of stuff but not being able to connect them. So I'll tell you about IR, I'll tell you about NMR, I'll tell you about this, but I can't actually connect them together into a whole to be able to resolve or explain or predict chemical structure. Then being able to do that, to be able to think beyond what you'd anticipate. So how we get there is, as I said, this differentiated questioning approach. So if the student came in and they got an average of 65, we'd start in the middle and we'd say, oh, okay, you use that question there and that data there, how would you apply that to a new case? So we always have a couple of new cases up our back sleeve that we can go back pocket, go, here you go, work that out, and the students work that through. If they do that successfully, go, oh, okay, well, what about the coordination chemistry? What sort of ligand are you working with? What are the conditions? Why is the UV-Vis showing a large peak here or a smaller peak there, or what's going on? So we had lots of opportunities to get them into that higher level. And we found, again, students responded very, very well. So research, well, we did what's called action research, or as I say, where to begin when you don't know where to begin. And so it was a unique moment in time. We had a group of students who had no experience of oral assessment. We had a group that had a hybrid understanding. They'd done some written, they'd done some online, they'd done some oral, and then those that had been entirely online and through oral assessment. Because perception is highly subjective, this is not the sort of quantitative evidence you saw in the previous one. I can't throw some stats into R and punch out some defensible data. It is about the narrative. And because it's a convenience sample, we just go to theoretical sampling. So that is, we keep going asking people the same questions until we stop seeing a difference. So that's where we ended up. So we interviewed staff and students, typically 20 to 30 minutes, audio recorded, transcribed after consent. And here are the 3 questions given to both staff and students, except for staff it was, can you describe your students' experience? Do you think it's an effective method to assess your students? And would you like to see more or less? So, I'll let you read these couple of quotes, one staff, one student. Here comes our Adelaide viewer sneaking in, nice and late. Just as I'm quiet too, Magda, good work. No apology necessary. So what you see here is a student reflecting on a lack of expectation coming in. I didn't know what to expect. I mean, I knew these people. I'd interacted with them before in the class, but I was nervous. So anxiety, is that a common feature for students, those who teach? Yep. All the time, more so with this generation coming through. They're very, very good at expressing their emotions to us, aren't they? Yes. Sometimes to my own detriment and sort of mental health. I go, oh my God, I don't need your problems. I've got my own. But for staff, this is the part that surprised me. I think it provides a more accurate reflection of what they know. Now, this is in contrast to the standard paradigm, a written exam. I mean, we've got some areas here at Curtin that are still test, test, exam, test, test, exam, test, test, exam. But I think they walk away believing they know the material more than perhaps in a written exam. And that surprised me, that my colleagues had that view. So the question is, well, why don't we do it? Why isn't it more widespread? There are some reasons, obviously. Student experiences still maintain that personal focus. How is it going to impact on me? What experience am I going to have? What outcomes am I going to get? They have a strong preference for oral assessment and a desire to mitigate those negative emotions like anxiety. Now, we just finished our Vivas last week, had a couple of repeats. Had one today, got one tomorrow. Had one that's coming in to do a written assessment on Thursday because it was tears. And that happens. So you just find accommodations around it. You'd be surprised by how much leeway we have to do things when you're doing things that aren't systematised like final exams. The staff responses typically remained impartial. So focusing instead on assessment design and delivery, potential improvements and the benefits for students. Now, while everybody thought that oral assessment was good and increased the quality of assessment, the real kicker is the administrative burden. How can I reasonably expect, because this is the thing we do in chemistry, it's fine for your second year unit where you've got 50 or 100 students, you can do that in 2 weeks, but what about my first year unit that has 300 students? Well, of course, it's not going to scale there. But is it important for it to scale there? Well, of those 300 students, 50 or 100 are going to go on to second year. So why would you do something that's going to benefit only a third of your cohort if you're lucky? And so it's appropriate at that time in that space. Some questions still remain. Why was the perception so positive in this space? And so that's one of the questions that still remains for us, that we can get by having a look at the thematic analysis. So here it graphs all of the mentions and comments of these themes across each of the abstracts and looks for coincidence between them, looking for strengths of association. And we find that for the middle here, it's around dialogue, it's around emotion, it's around experience, it's around knowledge. So the positive perception in this space is enhanced by that dialogic element. And why is it so front of mind for these students? Well, think back to what I described before. They're in a workshop, they're talking to others, they're talking to us. We have, almost all of them, have a personal experience with. Sometimes you do get students coming into a Viva and go, hi, I'm Daniel, nice to meet you. Well, welcome. First time they come to anything that I'd been in front of, and it's a different experience for that student. But for the most part, they know us. They know how we question them, because I'm very well known for answering questions with questions. Like, oh, why do you think that? Why you ask that question? What do you think? Why do you think that? Because you're trying to get students to naturally inquire about their own understanding. And so when they come into the Viva, they know that they're going to get that sort of questioning strategy. That positive relationship between the assessor and student is derived from experience and is in contrast to alternative assessment strategies. You don't, I mean, who does this? Does anybody get your students into a room and train them on how to do examinations? Give them skills on writing exams? Give them strategies to cope with exams? No, of course not. You just assume that they've done that at school or somewhere else. And that's not always true. students are coming to us now with a greater diversity of expectations, of experiences, and so I think this is just, again, a second example of how you can leverage that expectation and that understanding. And the things that students like is some logistics which focuses on clear criteria. And having the grading criteria linked to the questioning strategy meant that they're fully aware of, if I'm asking a question of what does NMR stand for, right? Can you decode the logic behind that, or that aspect of it is important. So because we did some action research and we used grounded theory, you should always end with some questions. So some questions that popped out at me were, are the pro-social factors, so that is the social elements, things that promote social interaction, within that perception part of oral assessment, a consequence of the same factors being intended within the learning design and observed in the current consequent environment. So in edu-speak, we would call that good constructive alignment. So think back to my original diagram with the overlapping Venn sort of spheres. Is that just an example of all of those three things overlaying on the assessment, and so we're pointing in the same direction? And the second question is, do the reported benefits of oral assessment outweigh the logistical barriers? I think that one's still out there. Again, we get a lot of pressure around assessment. Alex is nodding because workload, workload, workload. How many minutes per student are we allowed? It's technically 60 minutes per student for all of their assessment. So for all their assessment in the unit, it's 60 minutes per student, but yeah, there's always squeezes put on that because it's seen to be not necessarily worth our time. So the first question I can start to answer, and this is particularly because one of my favourite sort of psychological theories is the theory of planned behaviour. It says, what are the parts that go to mediating a behavioural intention? So the behavioural intention here is to succeed in my oral assessment. And so it breaks that down into three parts. Attitude towards that behaviour, the subjective norms that sit around that behaviour. So is it the normal behaviour? Is it something that exists within that particular environment? And do they have some perceived behavioural control? So do they have some control over both the intention and the behaviour? And so if I break that apart a little bit, I think the attitude comes from the oral assessment being just an extension of what they do in the workshop. That dialogue is vital. Their perception of success is mediated by that positive relationship. So it's just an extension of the banter that Emma and I, who co-teach this unit together, have naturally because, well, I don't know how to describe Emma, but she could probably describe herself. She's pretty loud and likes to have a conversation across us, and it's not always on topic. And I think students realise that both of us are humans as a consequence. So it does break down those barriers and means that we generally have a positive relationship coming into the assessment. And as I said, the oral assessment is merely an extension of the pro-social model of learning and therefore perceived to be easy. So they've got a fair amount of control over it. So some implications and limitations. Well, I think there is going to be some form of oral assessment into the future. There will be some improvements in the learning design to be able to provide more opportunities for dialogue, and that dialogue doesn't necessarily have to be synchronous. We don't have to be in the same room. Students these days do like to socialise in different ways, and so some of that is going to be online, through chat, through messaging and the like. And as written assessments return to campus, as they have this semester particularly, there will be some administrative pressure put on us to return to expedient modes of assessment. So it might not be best interest of the student, but it's best interest of the university because it's cheap, quick and easy. And I think the limitations are that we do have some mediated influential aspects between what we do in the classroom and that contemporaneous nature of needing to have 3 people in the one space to do an assessment at one time is challenging, but in fact is increasingly easy to do. So we have the Microsoft Office suite on campus. It has bookings, It's set up for your average hairdresser or plumber setting bookings, but it works for our benefit too. Students go in, pick their time, sends an invite to both of our calendars, done. So it's increasingly easier, but it is limited in scope for use in large classes. So I do want to thank Emma Pearson, my co-teacher in the course that I just described, Ben Eisel, who did his third year project with us a couple of years ago, and because that was part of a credit-bearing course, he did get some benefit from it. He got a degree, got his double degree, chemistry, chem-eng, and obviously we had ethics approval. I'd like to thank the WA branch for letting me share this work, and thank you for your attention. I answered them all.
I have a comment, and maybe some thoughts from Daniel.
Yep.
So a lot of forums that I've been part of are talking about using oral assessments more, particularly interactive oral assessments,
Yep.
because of ChatGPT
Yes.
and AI.
Yep.
So I guess, obviously you already mentioned you can't do it for like first year because it's
Yeah.
logistically not possible and it's probably not the best anyway. So have you thought about how like the university, because you're at a university level, or faculty
You're gonna ask me to put my policy hat on. I mean,
what are your thoughts?
the university has a policy, so any assessment can be confirmed through conversation with the student, but that's in addition to the burden already in terms of assessment. So it's going to be on the individual assessor to make that decision about whether they call in a student to query them about their assessment. Obviously that puts pressure on invigilated exams as a more normal part of assessment, and I think the university's put in some effort to have that return to campus, but it is in a fairly reduced form, I would say. It doesn't have the supports around it anymore. It's always just, I would encourage anybody, go back to your learning design, work out what is fit for purpose. If you are teaching primarily through written tasks and an exam is a natural extension of that, then that's appropriate fit for purpose. And I think particularly my colleagues in maths, that's how they teach. They teach through problems, lots and lots of routine, repetitious problems that are written down, and it's just that next step. Whereas for us, I contend something like this, where you're doing problem solving, it's not a monologue, right? So none of us as chemists sit in a room and solve problems independently. We always do it through conversation with our colleagues, and I think it's natural in these particular subject area where it is around problem solving that there is that element of dialogue.
I've got a question for you.
Sure.
So, yeah, when you was going through some of the examples, you showed the example of the coordination chemistry.
Yep.
And how would this change the NMR spectrum for this particular molecule?
Yep.
So how long would you generally give a student to answer that type of question if it's in an oral situation?
So that sort of example comes from primary literature. The students are given the paper in advance and told to read it, but it is pitched at a higher level when the students understand, and the sorts of analysis that our students do is not really included in primary literature because it is so fundamental. And so it just allows students to understand that the knowledge that they've got leads somewhere. And so they've seen that spectrum before, haven't got any of the interpretation, but they know this is the structure, this is the spectrum, and can make the sorts of steps. And if they can't, we help them out. I go, well, what sort of group's this? Oh, I think it's aliphatic. All right, where's that in the NMR spectrum? Oh, it's down here. Okay, so which peak do you reckon? And so we can start to give them feedback that allows them, again, at a low level, their grades at the lower end of the titration curve, but we can kind of step them through them. They gain confidence. They can then go, oh, yep, and something like a dirty great tetrazole, like that example, is probably going to be strong field, and suddenly we're into a whole lot of coordination chemistry that's interesting, and then, yeah, higher order thinking is starting to get into play there. Magda.
I apologise for being late.
So I'm sorry that I called you out. Only a little bit, but I am a little bit sorry.
And I'm really sorry I missed
No, it's okay.
the beginning, but I have to say I like the way where this is going, and I think, as Alex pointed out, I think with the ChatGPT and AI what's going on, we're going to have to, I think,
I had a student in my Viva this year that had taken the paper that I'd given him and produced a ChatGPT summary and brought it with him and attempted to read from it in place of actually explaining what he was doing. Let's just say it didn't go well for him.
So, and you know, we've had a lot of issues at my university, so I'm sure you have it here as well, with plagiarism, etc.
Yep.
So I think this is, I like to be able to assess students that way. It was interesting for me to see that students actually, sorry, I missed the beginning. With the
That's okay. Second year.
That they actually thought that was a good idea because your first years would be like, because they, but
It depends how you approach it. I mean, colleagues in a second year unit have previously tried to implement Vivas, but because it was a traditional lecture format unit, let's just say students vomited in it, like literally, it's just up chuck.
how could I implement it into my first years where there is a lot more students? I mean,
You
would
ca-
for example, would you ask the same question? Because then that's going to not work because they're going to say, oh, she's going to ask, you know, concentration of acids and
Yeah, look,
bases. You can't ask
it's.
the same question.
It could be just some, and I think this is where we're going to go. It's going to be around very sort of opportunistic moments of assessment, like in a lab, for example. And it might be around competencies, but basically you can say, oh, you just calculated that. Explain to me what you did. And they go, oh, yeah, verified that, students. You check off something on an iPad or device, and you've got that record there. And then you just do that cumulatively throughout the semester. Is probably how first year is going to work. Larger units, I've seen colleagues do sort of station-based Vivas. So come in, I'm going to quiz you on this content, and you stand up there and explain what you're doing, and then you move on to another colleague who does the second part, and you just got a sushi train of students coming in front of you. That's another way I've seen it done. But again, it needs to be fit for purpose. So scale is part of it, what you're doing elsewhere in the unit, and also the sorts of students that you're working with will also factor into it.
Well, if there's no more questions, let's say thank you very much again.
Thank you.
So we also have a little gift for you.
Oh, thank you.
So yeah, thank you very much. It's
Cheers.
a great talk.
Thanks, everyone.
That was-